This question falls under coordinate geometry and it's asymptote. But the problem is asymptote usually have linear expression upstairs and linear expression downstairs, but this one has a quadratic expression upstairs, so it's not a regular asymptote question. Pretty clear. So we have to write down the equation of the asymptote parallel to the y-axis. That means asymptote of x. So you take downstairs equals to 0, cx plus d equals to 0. That turns out to be x equals to minus d by c. That is the asymptote of x, or the asymptote that is parallel to the y-axis. So we can write question number A as write down. So 2x minus 1 equal to 0. That is going to be 2x minus 1 equal to 0, x equals to half. So x equals to half. That is the answer. That is the asymptote parallel to the y-axis, meaning the vertical asymptote. Question number B deals with stationary point, meaning turning point. Remember, question number 1 dealt with differential calculus product rule, and there has to be a quotient rule that was not given with that question. So this is the quotient rule separately given. So the quotient rule is d by dx of u by v is going to be v d by dx of u minus u d by dx of v divided by v squared. So the upstairs is u and downstairs is v. So we have y equals to 5x squared plus 10 divided by twice x minus 1. So d by dx of y is dy by dx, and d by dx of this side is going to be, let me write it over here, v, which is twice x minus 1, d by dx of u, which is 5x squared plus 10, minus u, which is 5x squared plus 10, into d by dx of v, which is 2x minus 1, divided by 2x minus 1 whole squared. So this turns out to be 2x minus 1, d by dx of 5x squared is 10x, and d by dx of the constant 10 is 0, minus, this is going to be 5x squared plus 10. d by dx of 2x is 2, and derivative of 1 is 0. And this is twice x minus 1 whole squared. So let's simplify this a little bit. So we can write 2x into 10x is 20x squared, minus 1 into 10x is 10x, minus 5 2s are 10, 10x squared minus 20, divided by twice x minus 1 whole squared. This turns out to be 20x squared minus 10x squared is 10x squared minus 10x minus 20 divided by twice x minus 1 whole squared. Now remember, we have to write at the turning point dy by dx is 0. So at the stationary point, gradient is 0. So dy by dx equals to 0. So 10x squared minus 10x minus 20 divided by twice x minus 1 whole squared equals to 0. We can write 10x squared minus 10x minus 20 equals to 0. We can divide both sides by 10. It would be x squared minus x minus 2 equals to 0 by 10 is 0. So we can do middle term break. So this is going to be x squared, we need minus x, so 2 ones are 2, so minus 2x plus x is minus x, minus 2 equal to 0. We can take x common, it would be x minus 2. If you take 1 common, it would be x minus 2 equals to 0. So this is going to be x minus 2, x plus 1 equals to 0. Therefore, x equals to 2 or x equals to minus 1. We have the values of x, but remember they said find the stationary point. We also need the values of y. So when x equals to 2, y equals to, we have to get back to the expression of y, 5x squared plus 10. So 5 2 square plus 10 divided by 2x minus 1. So 2 2 minus 1. This is going to be 4 5s are 20. 20 plus 10 is 30. 4 minus 1 is 3. So y equals to 10. So the first turning point is 2 10. When x equals to minus 1, y equals to 5 into minus 1 squared plus 10 divided by 2 into minus 1 minus 1. This turns out to be minus 1 square is 1, 5 ones are 5, plus 1 is 15, and this is minus 2, minus 1 is minus 3, so this is minus 5. So the turning point is going to be minus 1, minus 5. So let's restate the answer. So the turning points, stationary, since they use stationary point, I'm writing it. Stationary points are minus 1, minus 5, and 2, 10. Next question. We have to sketch. So let me do the sketching over here. Now obviously this is not a regular asymptote, so the sketch is not going to be what we usually have. Usually it looks like this. We have a vertical asymptote and we have a horizontal asymptote, and there is a boomerang over here, or it could either be over here, over here. So it looks like this. This one is not a regular asymptote because we have a quadratic expression upstairs, so this one is going to be different. So all we can do over here is find out where does it cut the x-axis, where does it cut the y-axis, and we can put the turning point, and that's the mention. Sketch the curve showing the asymptote parallel to the y-axis, meaning the asymptote x equals to half, and the coordinates of the turning point. That's all. So it doesn't even have to cut the y-axis and x-axis. So that's what they're saying. This is the y-axis, this is the x-axis. So x equals to half is one of the asymptote, so this is half. So x equals to half is one of the asymptotes, and the turning point, the first one is minus 1, minus 5. So minus 1 is here, minus 5 if it is here, then this is one of the turning points. And the other turning point, let me label it over here, minus 1, minus 5, and other turning point is 210. So if this is 2 and if this is 10, this is going to be 210. And now let's find out where does it cut the y-axis or where does it cut the x-axis. So we can find it very clearly when we put x equal to 0, y equals to 10. So when x equals to 0, y equals to minus 10, because it's minus 1 over here. So we can do this, y equals to 10 by minus 1, which is minus 10. So when x equals to 0, y equals to minus 10. So it's going to cut the y-axis at minus 10. So it is clear the turning point is going to be like this, a maximum turning point. So this is going to be, and obviously this is going to be the other way around. It is going to be minimum. So that's it. That's the sketch. The next question. Find an equation for the tangent to the curve at the point A. Equation of tangent or equation of any line is given by y minus y1 equals to m, x minus x1. So all we need is a point through which the line passes, and we also need the gradient of that particular line, and this is known as the point slope format of the equation of a line. So we know where it cuts the y-axis. It cuts the y-axis at the point A. So at the point A, let's write this down. We have to show this. So y equals to 5x squared plus 10 divided by 2x minus 1. Doesn't really matter what the equation is. It's ultimately the logic is the same. So at A, x equals to 0 because it's the y-axis. So y equals to 10 divided by minus 1, which is minus 10. So A has coordinate 0, comma, minus 10. Now we have to find the gradient. We know the point. We need to know the gradient. So dy by dx we already did from question B, where we found that it was 10x squared minus 10x minus 20 divided by twice x minus 1 whole squared. So we know the expression. So at A, x equals to 0, if we put it here, so dy by dx turns out to be 0 minus 20. This will be minus 20 divided by 2 into 0 is 0, minus 1 whole square is 1. So the gradient is minus 20. So if the gradient is minus 20, then the gradient of the tangent is also minus 20. Remember, gradient of the curve and gradient of the tangent, they are the same. It is not self-evident. You have to write this down. It is important. So gradient of tangent is minus 20. So equation y minus y1, so it is minus 10, equals to m, which is minus 20. X minus x1 is x minus 0. So this would be y plus 10 equals to minus 20x. Therefore, y equals to minus 20x minus 10. They did not ask for a specific form of the equation, so we can leave it in any form we want. Question number E is find the equation of the normal. So equation of the normal means the same thing, it's a line, but the gradient is going to be negative reciprocal. So at point A, the curve has a gradient of minus 20. So the gradient of normal is going to be the negative reciprocal of this gradient of the curve. So minus 1 by minus 20, which would be 1 by 20. Apart from that, everything else is exactly the same. So the equation of the normal is going to be, it is still normal to the curve at the point A. So it is 0 minus 10. So y minus y1 equals to m, x minus x1. So it is going to be 20 into y plus 10 equals to x. So therefore 20y plus 200 equals to x. That's the equation of the normal. We have one more question. Find the area enclosed by the tangent. So tangent and normal and x-axis. This is not area under the curve. This is more of geometry. Let's draw a little picture that we just did before. So this is the x-axis. This is the y-axis. So we had a picture over here, and this was the point A. This is A, where it cut the y-axis. So this is A. Now the first thing we had was a tangent at the point A. So we have a tangent. So at the point A, this is the tangent. Okay, so this is the tangent, and then at the same point A, we have a normal. So normal is perpendicular to the curve. So we have a normal over here. So this is 90 degree. So we have a tangent, we have a normal, and we have x-axis. So this is the x-axis. So this is the triangle whose area we have to find. So before we can find the area, what we can do, we can find out where does the tangent cut the x-axis and where does the normal cut the x-axis. We can find this out first. So let's do this. So let me write tangent here. Tangent. So at x-axis, y equals to 0. So the equation of the tangent is 0 equals to minus 20x minus 10. This is the equation of the tangent. So this is going to be 20x equals to minus 10. Therefore, x equals to minus half. 10 by 20 is half. Now, then we have normal. Then we can write the heading normal. We want to find what is the normal cut the x-axis. It cuts at the positive value. So again, at x-axis, y equals to 0. So we can write 20 into 0, which is 0, plus 200 equals to x. Therefore, x equals to 200. So this is the value of x. It cuts the x-axis at 200. And if we draw a miniature triangle over here, so if we let me do the sum over here. Let's move a little bit. Okay, so if we draw a miniature triangle over here, so this is 90 degree. So this is half minus half. This is 200. So this is 0. If you want to find the length from minus half to 200, so 0 to 200 the length is 200. So 0 to minus half the length is half. So this should be 200 plus half, or 200.5. So this is that value. Now the coordinate of A is 0 minus 10. So from here to here, this vertical, this height, since the y coordinate is minus 10, so the length is going to be 10. So we know the height of this triangle. So the area is going to be half into base, which is 200.5, into height, which is 10. So 5 to the 10. So we can calculate as 200.5 multiplied by 5, and it is 1002.5. So 1002.5.